Okay, now we'll be discussing the power of a power property, which asks the question, what happens if we take a number or a value and we raise it to a power, let's say 2 to the 3 or 2 cubed, and we raise that to yet another power, let's say we square that value. Well, what do we get? There's two ways of looking at this. First thing we could do is evaluate the expression inside the parentheses. So 2 cubed is just 8, and we're going to square 8. And we know that 8 squared is 64. Another way of looking at this is we take the expression in the parentheses and we actually perform the operation on the outside of the parentheses. We square that value. So if we're going to square 2 cubed, we're just going to multiply it by itself, where we get 2 cubed times itself. We can use the product of a powers property to simplify this to 2 to the 3 times 2 to the 3 is 2 to the 3 plus 3, which is 2 to the 6th power, which is also 64. So why would we want to look at it this second way? Let's explore this a little further. Let's say we have 2 cubed and we raise it to the 5th power. Well, that's just going to be 2 cubed multiplied by itself 5 times. Let's see what we're going to get here. 2 cubed times 2 cubed 5 times. So how would we simplify that? Well, since we have like bases, we can add the exponents, but notice we're going to add the same exponent a certain number of times, and this number of times is always going to be this outside exponent, this power of a power. So we're just going to add this inside exponent, the 3, 5 times. So it's going to be 3 plus 3 plus 3 plus 3 plus 3. Another way of expressing this is we have 2 to the 3 5 times, or 2 to the 3 times 5, which is just 2 to the 15. And that, if you want to get a value, if you use your calculator, that evaluates to 32,768, which isn't really important right now, but it's always good to simplify your terms. So let's try this with a variable. Let's say we have x squared and we raise it to the 4th power. Then what would that be? Well, we just have x squared multiplied by itself 4 times. So that'll be x squared times x squared times x squared and finally times x squared. And so here we're going to have x to the 2 plus 2 plus 2 plus 2, or x to the 2 times 4, which is just x to the 8. So you can see the pattern that emerges here. We're always going to add this inside exponent this many times by the outside exponent. So the new exponent is going to be the inside exponent times the outside exponent. In this case, 2 times 4. In this case, it was going to be 2 to the 3 times 5. And in this first case, it's going to be 2 to the 3 times 2, which is exactly what we end up with. So we can extrapolate a general rule. If we have a value a and we raise it to the nth power, and then we raise that to the mth power, then we can simplify that by saying a is raised to the new power n times m. And that is our power of a power property. All right, so let's use the power of a power property to simplify each of these expressions. Pause the video and try them on your own first. All right, let's see how you did. So x squared raised to the 3rd power is just going to be x to the 2 times 3, which is just x to the 6th power. Number 2, this is going to be 2 squared to the 5th power is going to be 2 to the 2 times 5, which is 2 to the 10th power, which you can simplify by writing 2 to the 10th power, which is 1024. 1024. And this third one it seems a little bit more complicated, but it actually isn't. All you have to do is you have to simplify the numerator, then simplify the denominator, and then simplify the entire fraction. So x to the 3 raised to the 4th power is going to be x to the 3 times 4, which is going to be x to the 12th. And the denominator is going to be x squared raised to the 5th power is going to be x to the 2 times 5, which is x to the 10th. And then using our quotient of powers property, we're just going to take the difference. This is x to the 12 minus 10, or x squared.